Okay, so I apologize for the poor video and audio quality, but I just want to give you a tour of some of the Lego creations that I currently have put together. I have a fair number. If you watched my nodal analysis video, you know that I love to follow instructions. I can think of no example that's better to describe this than putting together a Lego set from instructions. If you've never done this before, you'll see that everything here is step by step and gives you very clear, straightforward steps. Lego. Well, this idea can be applied to what we call loop or mesh analysis. Mesh analysis is like the cool older brother to nodal analysis. What I mean by that is that the numbers tend to work out nicer and it becomes significantly more easy to do the nodal analysis. It makes the math easier. We're still going to use the acronym ACT. Step 1 will be to assign loop currents. We're always going to assign loop currents in the clockwise direction, and we don't care about ground. Step 2 will be to apply KVL for each loop and use Ohm's law. Step 3 is going to be solve the simultaneous equations. The observant viewer should notice that if we get all of these currents, we're going to have all the quantities we need in the circuit. As a result, nodal and mesh analysis are really equivalent strategies that give us the same stuff. To understand this method more clearly, let's do an example. The first step is going to be assign loop currents. We will always assign currents as clockwise and we do not care about ground. I'll set the top loop to be I1 and work my way around the circuit. Step 2 is to apply KVL. Let's start with loop 1. We will take whichever sign the voltage has as the current enters, and voltage across the resistors will always be positive. In loop 1, we have plus 5 volts, plus the voltage across the 2 ohm resistor, which is 2I1, and then we come to the 3 ohm resistor. Now we should notice there are two named currents acting on this guy, I1 and I2. So this current is a little tricky. We have the current in the loop we're in, and we have the current in loop 2. What you should notice is that the current in loop 2 opposes the direction of the current in loop 1. So how we're going to handle this is we're going to say the voltage across the 3 ohm resistor is 3 times, in parentheses, I1, the loop we're in, minus I2, the current opposing, and based on KVL, this sum is equal to 0. We can simplify this into one equation, which is minus 5 I1 plus 3 times I2 equals 5, which is equation 1. Moving to loop 2, we're going to get 5 times I2 plus 4 times, in parentheses, I2 minus I3, plus 3 times, in parentheses, I2 minus I1, and all of this equals to 0. We will get a simplified version, minus 3 times I1 plus 12 times I2 minus 4 times I3 equals to 0, which will be equation 2. Finally, in loop 3, we get negative 10 plus 1 I3 plus 4 times, in parentheses, I3 minus I2 equals to 0. Simplified, this is minus 4 times I2 plus 5 times I3 equals 10, which is equation 3. Next, we move to step 3, solve. The first matrix is minus 5, 3, 0 on the first row, minus 3, 12, minus 4 on the second row, and 0, minus 4, 5 on the last row. The next vector is I1, I2, I3, and this all is equal to 5, 0, 10. Taking A inverse times B, we get our desired unknowns. Plugging this into MATLAB, we're going to get that I1 is negative 0.57 amps, I2 is 0.71 amps, and I3 is 2.57 amps. Again, you can get any other value you want, including power or voltages in the circuit now that you have these current values. Well, we've discussed several small, easy steps, much like building a Lego set. Lego. This really appeals to the engineering side of my brain. Hopefully, you'll find this straightforward and easy to apply to circuit problems. If you think I've earned it, I would love it if you would share this video with others and if you would subscribe to my channel. You can connect with me on Twitter or Instagram at McPheron. This is Dr. McPheron. It's been a pleasure. Lego.